Welcome everyone. In this video we will go over how to draw free body diagrams in detail. Now the first question that should come to your mind is, why would I even care? I mean, who needs a free body diagram? Well, I argue that they are quite important while dealing with mechanics problems, and my number one reason for that is free body diagrams, which we abbreviate as FBDs, are very helpful to write force equations. And of course, especially if you're dealing with Newtonian mechanics, force equations are pretty much the only things that you care about. If you're doing like Lagrangian or Hamiltonian mechanics, you won't need force equations and you won't write force equations. You won't even draw a free body diagram. But if you're doing Newtonian mechanics, which is probably what you're doing early in your physics career, early in your physics education, force equations are the most important thing for you, because using them you can find acceleration, you can find, maybe there is a mass pulley system, you want to find the tension in the rope, or you can find relative velocities using relative accelerations by finding the separate acceleration of each object. So what I'm trying to say is, force equations are incredibly important. And drawing free body diagrams really help you to find those force equations. So how do we draw free body diagrams? Well, there are a couple of guidelines, and of course you can take out, maybe add some, depending on your taste, maybe on the parts that you struggle with or the parts that you do with ease. But when I thought about it, I kind of decided on these things. So first of all, you want to draw the object by itself. And what I mean is, maybe let's say that we have an incline like this. You have object 1. That looks horrible. Let me draw it one more time. You have object 1. On top of it, there's object 2. And maybe there is a pulley with another one, object 3. Let's say that I want to draw the free body diagram for 1. When I do that, I don't draw 2. Okay? I only draw 1. It's there. Okay? Well, maybe it's better to draw it as it was oriented in the question. But we only draw it. And in fact, this is the second part. If there is no torque calculation, that means if you don't need to account for the distances, and this kind of a question would not require you to account for the distances, you don't even need to draw a box. You can just draw a dot. Okay? And for example, in this one, you would draw the dot. There is mg downwards. There is the normal force by the inclined plane, which is n, let's say, and the 2 will be pushing it down. Maybe you say, I don't know, n1, maybe that is n1 perhaps. And there is tension by the rope, which is along the incline, and perhaps there is friction. Maybe there is not, we don't know. Let's say that there is not. So that will be your free body diagram. Okay? But that's not done yet. Okay? That's not done yet. And we will discuss why it is not done yet. So we said object by itself, and of course, obviously, you want to draw all the forces. You want to draw all the forces that act on the object. Don't come here and draw the weight of M3, okay? Don't come and draw the weight of the third object. It's not acting on the first one. This is the free body diagram for the first one. And of course, you might need to draw a couple of free body diagrams, and that's completely fine. And one other important thing is that you don't draw components. So, no components. And what I mean is, maybe you choose a coordinate system like this, x and y. Please don't do this. You have mg, right? Don't do it like this. You have mg in the x direction and mg in the y direction. Don't do this. It's not necessarily wrong, but I know that people, when teachers are grading exams, I know that they take off points from this. And me personally, if I were to grade someone's paper, I wouldn't take off points from this. I wouldn't even care. But besides that, I do think that this is not helping this is not really helping you to visualize what is going on, because you will need to determine these components, right? And how do you determine these? How do you determine these? You might say, oh, I just use trigonometry, but how do you see the angles, right? You don't need to separate to the components. What you do is you just write the force, and then let's say that this was given as theta, which is very common in inclined plane questions. Then you can see that this will be theta, okay? I don't want to waste time here, but you just draw like a dash here and this. You will see that this angle is theta, okay? And so what I'm trying to say is, you draw the angles. So let's say no components, but angles. You draw the angles, and using the angles, you can now see that there is a y component and the x component, okay? There is no need to label the components separately. You just write the force itself, and then using angles, you write the components according to your coordinate system. So let's say also that we choose a coordinate system. This is incredibly important. This helps you to not mess up negative and positive signs. And this is one of the reasons why you don't separate the components. Because let's say that the question did not give you a set of axes. You determine them yourself. You choose them. In that case, someone may choose a different x direction than you chose. And in that case, the x component of any force will be different than yours, right? If I choose the xy as this, well, then the xy components of mg that we erased a couple of minutes ago, they were not the xy components. They are the xy components according to this set of axes. But someone might choose this one. So that is also another reason why we don't write components in the free body diagram. So you write the coordinate system, and ideally you would be, and I won't even write this as a step, but ideally you would be drawing the lengths of the arrows to represent the magnitudes of the forces. The strongest force should have the longest arrow, but probably when you start a question, you won't know all the magnitudes relative to each other, so you don't really need to think about this, okay? But let's say that there is someone jumped out of a plane with a parachute, of course, no safety problems, okay? There is a parachute. Although I wouldn't advise you do that. I wouldn't do it personally. So maybe you jumped off with a parachute, let's draw it like this. Oh, that looks horrible. But anyways, you know that the person is accelerating downwards. If I were to ask you to draw the free body diagram, you would say, we have a dot. The person, the box, an elephant, anything, you represent it with a box if you are not doing torque. And in that case, there is mg downward, the weight of the person, and there is, let's say, drag. I drew it, as you can see, smaller than mg because I know it is accelerating downwards. The person is accelerating downwards, okay? If you know that, represent the relative magnitudes by considering the lengths of the arrows. But if you don't know, don't even think about it. So that was it. And also one other important note, when you are drawing force diagrams, free body diagrams, don't write formulas, right? Maybe you're returning to the question, returning to this one that we just erased. You might know that the force of drag in air is proportional with velocity. So don't come here and write kV, okay? This is fine, but think about it. Maybe there are lots of forces. Maybe there is, maybe you have a particle, a charged particle. There is let's say, a magnetic field acting on it. Maybe there is an electric field. Don't come and write all of the values for this, okay? Maybe you even consider the weight somehow. Maybe there might be some other force, some other attraction. Okay, don't come here and write, the This is going to be QVB, let's say, I don't know. And this is going to be KQ. I mean, you get the idea, I hope. I mean, don't come and write the formulas for the forces. Just write the label, and then when you're writing the force equations, you write the explicit formulas for each symbol. And last but not least, if you are doing a torque question, maybe something is rotating or it is in equilibrium, static equilibrium. In that case, you do not want to draw a dot, okay? You want to draw an extended object. Let's say that, I don't know, maybe you have like a road here like this, and there's a person standing. We know that the road is not rotating, okay? And I want you to find, I don't know, the weight of the person given a couple of magnitudes, couple of distances maybe. And in that case, if you are drawing the free body diagram for the road, you can't draw it as a dot because that won't solve the problem. You will need to represent distances. You will need to do torque calculations. So you draw a extended object, okay? And that's pretty much it. I mean, drawing free body diagrams, they are not that hard. If you do like a couple of physics problems, you practice with them, they become very easy and you will intuitively draw them, hopefully. And please, don't go over them. I mean, go over them, but like, don't ignore them, okay? You really need to draw these. You really need to write these because, I mean, personally, I experienced this. I say, oh, this is a very easy question. I did this a billion times. I don't draw a free body diagram and I end up getting it wrong. It happens, okay? And when I look back at it and I see, oh, I didn't draw the free body diagram. There was this that I didn't account for. So really, really take this seriously, and it is easy. It is fun even. So yeah, that's it basically. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.